Tab data that we are able to obtain or try to obtain is a byproduct of system design, equipment selection, system installation, system operation, and proper usage of our, instrumentation. I knew I could outlast her. Any of those 5 items there can create our challenges in the tab industry, getting data that's accurate, repeatable, meaningful type data to be used by the design professional, be used for the project. So those are the things we're going to try to focus on as we go through the presentation. The one thing that I want to try to emphasize is we're trying to forward think on projects, forward think on what we're doing, not wait until we're on job sites to try to get that information and say, hey, by the way, we should have. So the key thing that we're always looking at is project planning. I listed as project document review. In essence, starting early can be the conversations we're having now, no project involved. It could be talking with equipment suppliers when they're talking and going through things and they're talking about the great bells and whistles of their air handling unit. Well, you know what? It's a rooftop unit. I want test ports installed on that unit so I can take static pressure profiles and get some airflows and temperature measurements across it when it's outdoors. Starting that early conversation of things and thinking system-wide of what can we do to get measurements and get data accurately and that type of thing. The biggest thing that you're always going to see quite a bit is what I talk about as system. System. It's trying to get everybody thinking in that mindset. It's the hardest thing for a lot of people to do. They get focused on that piece of equipment. They get focused on just what's going on in that scenario. They're not looking at the whole picture of the whole chill water system or the whole supply air system. So we always try to figure out what's meaningful data, what's accurate data. We always try to think if we can repeat the data and repeat the scenario, we've got a pretty good comfort level that we've got some accurate data. Meaningful data, we're always trying to say, are we getting numbers? Are we getting data that's benefiting the project, benefiting the owner? It's not just numbers to get numbers. We don't like to think about matching numbers. We like to think about getting data that's going to make a difference and really truly tell you what's the system doing. How's it performing? Is it meeting design intent? Is it not meeting design intent? And we always say, don't get hung up on the numbers. Once you think system. You know, if I'm not getting my design airflow into this room, think system-wide, is that going to affect the whole picture of what's going on? You know, if I'm 10% low or if I'm 10% high, and start thinking about system-wide and what can be done or what should be done. Yeah, let's get it to where it needs to be if it needs to be. If not, hey, here's why, and have the justifications of why. So, and when we start thinking meaningful data and accurate type data, that's where we start thinking, what can we obtain? You know, a good example is wet bulb temperatures. If we need to get wet bulb temperatures off that cooling coil, one, we got to step back and say, can I establish a latent load on that coil? So when I start taking those leaving air temperatures and those leaving wet bulb temperatures, it makes sense that I had a load on the coil and the numbers I'm taking are making sense and correlating back to the design parameters of the coil. Is the chill water coming into the coil? Is it steady state? We got to go to 42 degrees coming in or whatever our design water temperature is, and we've got that latent load. If we can't establish that load and we start taking numbers, does the data make sense? You know, are we taking a single point measurement on that coil? In that single point measurement, do we have stratification of airflow through that air handling unit? If we do, hey, we better be getting a traverse of airflow measurement, or I'm sorry, of temperature measurements. So when you look at that scenario, look and saying, hey, am I getting data that's meaningful? But then also I can step back and, like I said, repeatable. Can I repeat that data and get that data again if I set up the scenario the same way? So let's start, and we start looking at airflow. And we start looking at the different scenarios, and we say, hey, I'm going to design a system. I'm going to have outdoor airflow measurements. Y'all, today, outdoor airflow measurements are becoming very critical, required on all jobs. Everybody wants to know how much outdoor airflow is coming in through my system in certain operating conditions. You got to start looking and saying, early on, did I give enough ductwork for traverse information so I can actually traverse the airflow? You know, you got a minimum outdoor airflow coming in here. your economizer airflow, and you've got this nice ductwork coming up through here. Can I actually get an accurate measurement if the system's laid out that way? So when you're looking at documents and you're going through things, you're talking early on, hey, you know what? If I get some better ductwork layout, if we can do this or do that, you know, too often you see that air handler butted right up to the outdoor air louver. You know, so you're trying to get an outdoor air louver measurement or do something like that. By the way, that's not the way to do it, so, in that side. So that's what we want to try to look at ahead of time. When we're looking and reviewing documents, or we're sitting down and going through things early on, hey, how am I going to get outdoor airflow measurements? Are these critical for you? If they are, let's find, oh, we're back. We'll find a new way to lay out the ductwork, a new way to work with it. You know, like I mentioned earlier, rooftop units become a big challenge. How can you measure outdoor airflow on a rooftop unit? You know, we'll talk about the use of the flow hood in a little while, but you know, you can't put the flow hood on the back end of it and get an accurate measurement. So start looking and saying, am I going to get a mixed air temperature measurement? Can I do that? If so, are there test ports installed in the right spots on the rooftop unit? I'm in the mode, and I know not everybody is, but I do not like to drill out a rooftop unit. So the key thing at that point would be is making sure the manufacturer provides test ports. You know, they got the vent locks or something in that neighborhood installed on the rooftop unit so you can actually get your measurements across. Or if you want a static pressure profile, if you want temperature measurements or something on that side. So something early on to look at. Talk to the equipment suppliers. Hey, a lot of times now you got the packaged rooftop with the packaged heat exchanger, and they're close coupled in the roof curb for the outdoor air to the rooftop. No way to get an airflow measurement on that heat exchanger, the cross plate, or even if it's a wheel. Today, in our area, we're starting to see them. They're giving us factory test ports to measure pressure drop across that heat exchanger. Correlate that back to the charts they produce for airflow. So they're giving us some options now, but that doesn't come about. The manufacturer doesn't want to have to do that if it costs them more money, right? But in the long run, when it comes back to saying, hey, I've got to produce and prove that my unit's performing, and the tab guy comes in or the commissioning people come and say, we can't really produce what that airflow is, there's no way to get a measurement. Factory test ports early on would do that. So open the conversation early, get through that so that we can get to a situation to get some good data. Keep in mind the primary preferred method for airflow measurement is a duct traverse. That's what we want to live by. That's our most accurate method or means of providing an airflow measurement is a duct traverse. You know, you can look at and say really 2.5 diameters from any condition is what you want for an ideal traverse plane. For rectangular duct, you use your equation there, and that gets you your equivalent length. Round duct, it's just your round duct diameter. So the one aspect is location. The second side is better than 1,000 feet per minute. Get you more accurate readings on that side. So as an example, a 30-inch by 20-inch duct for 10,000 CFM, you need approximately 6 foot of duct. So on a 30 by 20, how often do you get 6 foot of duct for an accurate traverse location, an ideal traverse plane? Very seldom. I mean, you see some lovely stuff like this in the field. Tap off the side, go up underneath. Believe it or not, that did go supply. That was some supply air going off to a grill back to the other side, in that side. But you see a lot of things that get done and say, hey, if that airflow measurement needs to be an accurate airflow measurement, we're going to go buy a duct traverse. And so mainly when you're starting to look at air handlers, rooftop units, big supply units, we definitely would love to get a duct traverse on those. So getting and looking at the drawings and looking at the documents saying where are we putting things, where are we putting air handlers and that type of thing. And we know how easy it is with architects to say, sorry if there's any architects in here, we want more space. You know, if you give me a larger equipment room, I can get a straighter duct run to get more accurate airflow measurements and that kind of thing, and they're going to look at you and say, yeah, right, we want square footage. So one thing that did come out, and I'll show you in a sec on the next thing, of getting equipment space is a nice study that was done. But first off, on duct traverse, even if we don't have that ideal traverse plane, it's tough to say a poor traverse is better than no traverse at all, but we would still love to take one. And when we take one, if we meet some criteria that they've done some studies on, AABC just published it in their national standards, that if your velocity profile is good, basically if you have no zeros, no negatives, and you're within a tolerance on your velocity profile, you've got a pretty good duct traverse. You might not be in that 6 foot, you might be 3 foot, but you ended up with good laminar flow through the duct, and you've got a good, accurate, repeatable measurement. So a lot of times we'll go ahead and take one and see what it says. And it might come out and say, we got a lot of zeros, a lot of negatives, the duct's hugging one side of the duct. We cannot get a good measurement here. So always try it. Keep in mind, once again, that a lot of times comes back to the tab tech and using his instrumentation properly, and also using his judgment to a point, saying, hey, I've got a good traverse, this is good. And even at that point, report the velocity profile so you can see that it was a good traverse. Only if a duct traverse is not accurate, that's when we start getting a little creative, and we start saying, hey, let's do a face coil velocity, let's do a filter velocity reading, maybe possibly some of the airflow of the outlets. That can get a little interesting. If you have duct leakage, you might have some issues and challenges. If you have a lot of outlets, that can be a challenge. You might break it down at that point and take multiple traverses and do something that way. That might not be a bad method. Another option is summation of calibrated VAV boxes. So once all the VAV boxes are calibrated, open the system up, and then you're just going to read those airflows off the computer. Gives you an idea. You know, you're at the mercy then of the tolerances of the DDC system, as well as some measurement tolerances. So to give you an idea, it's better than nothing, but if you have no way to get a duct traverse and get some airflow measurements, you can look at that. You know, and you might even be able to break up the system then and start saying, hey, I got one main branch. I'm going to do my total by VAVs, but you know what? Here's a main branch that has 60% of the VAVs, and I can traverse that branch. Take a traverse, get a comparison to the VAVs. You know they're not going to be 100% identical, but you know what? If they're in the ballpark, you know you're going to be overall close in your numbers. So some of the things in looking at it is the data that we can produce as a tab professional once again gets dependent upon how the system's operating, how it's installed, what's available to work with. So keep that in mind in that side. So we love a traverse. Everything we try to do airflow measurement-wise is always backed up by a traverse. The one thing, like I mentioned, ASHRAE back in 2006 published this article, System Effect Factor, How It Affects Operating Cost. School district up in Canada did a study on all their schools and started trying to determine how much system effect was having on all their air handlers, all their fans throughout their facility. Large school district. They were going through looking at and started saying, if I had a straight duct run and I could decrease my static pressure on the system, I didn't have to worry about system effect, I would save a ton of money. So in one example, they were reducing 6.77 horsepower on one air handler. Basically, they were saving roughly $1,200 a year if they had a straight, good duct run without system effect on that one air handler. Then they took that number out over 25 years. Life cycle cost it and was $86,000 for that one unit. So you can imagine a school district with a ton of fans, a ton of air handlers, what kind of money you're talking. So there's the argument back of giving me space to get straight duct runs. You're definitely going to outpay the square footage costs that you're going to use to get a straight duct run. So very good article. Like I said, you can, good thing about ASHRAE, get back onto their website, get back to their old articles, get some things. But great thing of looking and saying, if I limit system effect, have good straight duct runs, you're also giving a tab professional a great place to take a duct traverse. So. Fan curves. A lot of times we can say, well, hey, let's just use the fan curve, get your pressures, we'll go off a fan curve and get your numbers that way. Be careful on fan curves, produced under laboratory conditions. So a fan curve is produced how we'd love to have the ability to take our measurements. But as we know, we're not getting those every time out in the field. Free inlet, straight discharge, ideal traverse plane. The other thing that they do is they extrapolate a lot of their data. They'll test a fan of one size, they'll extrapolate, calculate out the next sizes up, produce those as fan curves, produce those as fan tables. So a lot of times that data is a little skewed. The other thing, did a pump presentation yesterday that we cannot do at the fan. You can, I guess you can if you want, not recommended. We can do a shutoff head on a pump and establish the right impellers installed, as well as establish a good baseline now and correct a pump curve. You really can't do that with a fan. You don't want to do a shutoff head on a fan and Loctite it, turn it on and do that. So you can't correct a fan curve like you can a pump curve. So that's why you'll see use of pump curves, but you won't see use of fan curves a lot of times. You can plot the points, see what you have. A lot of times the static pressures that we're able to obtain in the field aren't the ideal static pressure points that they're using in the AMCA labs. So know the limitations. Sometimes they'll help you out. They'll definitely help you troubleshoot. But a lot of times they're not going to get you ideal airflow numbers. Once again, another article way back November 2005. Governor, engineer out of Governor, put some data together, started going through it. It was kind of funny. Fan data is what you see, what you get. The basic answer was no. That's the published fan curve. 2 different field measured conditions of 2 different fans and 2 different units. They were more than, 65,000, and they're actually at 55,000. They weren't producing what the published fan curve said it would produce. They found that fairly consistent. The range was, I think, 7% to 30% off on fan curve data. So once again, be careful when you're using it. Not saying don't use it, but don't always expect it to match up and use that as your fail-safe. I'd rather probably rely on a poor traverse than I would in using fan curves. Looking at equipment and the different options of airflow, and you're looking at airflow measuring, airflow monitoring stations, we start seeing the use of these quite a bit now. Give us a lot of flexibility for measuring the airflow, controlling systems, and doing a lot of things differently. Reporting outdoor airflow, so the owner has documentation of how much airflow they're bringing into the building. Controlling building pressure, a lot of different options. The big thing is making sure they're applied correctly, they're installed correctly, and that type of thing. I mean, this is the intake of a rooftop unit. Minimum outdoor on a rooftop unit. Ironically, in southern Iowa, sitting up on a roof, middle of a farm field is a health center facing due north. And then the day I was there, they were complaining they weren't reading right and they were having issues. They were having building pressure problems because their minimum air dampers were going up and down and all kinds of things. There were 6 rooftops like this. The best part was when I went up to this one here, I shook it a little bit, water just came dumping out of the tube because it just rained that night before. So, great idea, have some outdoor airflow monitoring capabilities, but that's really probably not a good installation or application. You probably can't see it right here. That's your thermistor right there. It's covered in lint and dust. And it's basically on the outdoor air. It wasn't reading well. Once again, building pressure problems for the outdoor air. Went through a compressed air and blew out all of their airflow stations, cleaned them all out. Building came right back in. You can just hear the building breathe right back in. So at one point, several manufacturers said you don't even need to filter the air. I would highly disagree, and I think most of them now have changed their installation manual to say it should be in filtered air. So if you have one installed in an outdoor air intake, you probably still need to have it filtered. So get them filtered. The other thing that you'll run into with airflow monitoring stations quite a bit, you have a big outdoor air intake, or you have a big supply airflow, call it 50,000 CFM, and all of a sudden now you want to modulate that system down to even 10,000 CFM. Will that airflow station still operate correctly at the lower airflows? That's the thing. What's the range? Will it work at those lower airflows? Typically we see that once we dump off, if it's calibrated at the 10,000, it seems to work okay. If it's calibrated at the 50, it works okay. Working at the opposite end of what it was calibrated at has a challenge. Some of them do have the opportunity to calibrate that airflow station on a curve. They work a lot better, but then you still run into that problem. If you get too low in the airflow, you lose your air pressure in the duct, you lose your velocity profile in the duct. So if it's a sensor based on pressure, you're losing pressure. If it's based on airflow velocities, you're losing air velocity in a large duct, you start losing the accuracy of the sensor. Because a lot of times they'll tell you what their range is velocity-wise on the sensor or pressure-wise on the sensor. They're not giving you a range of airflow that sensor is going to work on. So be very careful when you start looking at those and saying what's going on with my airflow station. The other thing, a lot of times in a unit they're located close to the dampers. Damper starts closed and you create turbulence. You got turbulent airflow now going across your airflow station. It's not reliable. So be careful with airflow stations. We love having them. A lot of times now you're seeing them on inlet of fans that seem to be fairly reliable. We still like to field calibrate all airflow stations. A lot of times if we don't have a duct traverse to compare to it, like very impossible to calibrate that airflow station, because where are we going to take a measurement to do it? So sometimes you get creative and say, okay, I'm going to put the unit just in 100% minimum outdoor air, close the return air, close the outdoor air, back the fan down, and then I get a supply traverse in the duct downstairs, traverse that duct, then compare and calibrate the airflow. So there's things you can do, and you got to think your way through some things, but those are things we want to do up front on a job, making sure we're all on the same page of how we're going to try to do something to get the data and make sure, hey, there is a place to traverse downstairs. Okay, we'll do it that way. So, tolerances. We start talking about different tolerances and making sure measurement tolerances are within plus or minus 10 is usually the industry standard. Think about what the tolerances are. We were at a project and the tolerances were 0 to plus 10. So we tried to set everything up on the supply airflow at 0 to plus 10. Our paperwork, we're able to get that, and we always made sure we're on the upside of all our VAV box calibrations and all our airflows. We come back then to prove up, and we start going through it, and we have numbers that are -5, some things like that, and going through it. Started thinking about it, and the controls contractors are working with us, with the commissioning agent and the engineer. The controls guy goes, hold on, time out. They're fine. We're not. We're plus or minus 10 on our VAV box control. So we're letting it control down to there. And they're saying we can't, for some reason they couldn't change the tolerance on that system that way. So making sure all the tolerances match up in that side of where are we going with the job, does it need to be, and that's when the engineer said, well, hold on here. You know, these are a bunch of classrooms, we're okay, it's comfort cooling, I'm not worried about that. So we went over to the lab side, and it was funny, then he had changed his spec to plus or minus 5% on the lab side. The ironic thing about this project, the room was too tight. They were so tight that we had to bring on a positive room, exhaust airflow up so high that we were outside of a 10% tolerance. And he said, well, you got to get your airflow back in tolerance. Well, we started saying, well, we get that back in tolerance, watch what happens to your room. It went overly positive. So once again, you start looking at your tolerance and say, what tolerances apply to what part of the project? Are those tolerances really required in that scenario? If you're in ORs and critical rooms, everybody likes to go back to plus or minus 5. And it's funny, even the AABC, the new edition that just got published, we come down and we say plus or minus 5 on operating rooms and other special environmental rooms with 2 or 3 outlets. There's already a revision circle on that in the new thing. We start revising the standard, ironically, about the day after it's published, to make the ANSI 5-year cycle. So, you know, it's really going to be dedicated and predicated by the building envelope or the room envelope. The looser the envelope, the more airflow you're going to need. The tighter the envelope, the less airflow you're going to need, as long as you maintain your air changes and that side. So get to critical rooms, it's more, hey, let's watch out for our air changes and our room pressure. Let's not worry about our plus or minus 5% airflow out of that outlet. You start talking about all the different tolerances, and once again, we're back now to equipment selection, equipment installation. If I have balancing dampers like this, it's awful tough to get tight tolerances. You know, if you need tight tolerances for your airflow and the balancing of that airflow, make sure good dampers are installed. Make sure quality balancing dampers are installed to where you can actually lock down handles that are reliable. They actually can almost see, they're not designed for seal off, but you can actually reduce your airflow. I mean, we've seen several situations in dampers like this style that a lot of contractors will just make in their own shop, that you'll close it all the way and you'll still get 100, 200 CFM out of that damper. So the close off is very poor, let alone at that point then, if you're trying to balance down to 50, how are you going to get it down to 50? You know, you're not going to with this type of damper. So make sure the quality dampers are specified and the quality dampers are provided on the job. The other thing, when you look at surface mount type grills, any wall type grills, getting airflow measurements of those type of devices is very difficult. becomes a little bit of an art unless you can get a duct traverse. So what we'd love to do in this scenario here, we'd traverse the duct. It might even be before and after that. And then the difference between the two gets us our airflow. You can get a face velocity on it, but there's a scoop behind it, so what's going to be your free area? So you start running into challenges, what's my free area? If there's a face damper in there, what's my free area that I'm going to calculate my airflow off of? So any surface-mounted duct or surface-mounted grills become a big challenge of getting airflow. If we can get to a scenario, traverse that whole duct, and say there's 4 of them on there, and we got total airflow, at that point then we might say we just want to make sure we proportion out that and get an equal velocity across it. You know, especially if it serves a common area. No sound issues, no draft issues. Make those notes in the report of what you've got. That way everybody's comfortable with what we're sitting at. And we're not sitting in a situation of a guessed airflow because we couldn't get a good K factor established on that. So I don't know if I think some of y'all were in David Harrell's presentation yesterday on establishing correction factors. And it always goes back to that duct traverse. So sometimes when we get layouts like this, we look and say, okay, how are we going to present airflow? How are we going to do it? We're going to get you total airflow, calibrate the VAV box for that, then we'll get you a face velocity and do this. Make sure everybody understands up front if they're okay with that. More and more now, you start seeing a ton of exposed duct work on jobs. I guess it's kind of a nice compliment to our industry that everybody wants to see it. So, face dampers, they are a very, very difficult thing to work with. They do not divert or proportion flow. They eat up static. So if this had a face damper in here, I would close that down some if I needed more airflow further downstream. Most of the time it just ate up static. I'm not diverting a lot of airflow, especially if you get into ducted systems. So if you're ducting off to a bunch of bathroom exhausts, risered up in a hotel, and you have a bunch of face dampers, when you close that face damper close to the fan, you're pushing a little more airflow down, but you're not pushing the airflow you think you're going to get. When you cut, say it's producing 150, 150, you cut 100 out of that and you measure 50 now, you're not pushing that extra 100 down there. You've put a lot more static on the fan and reduced the capacity of the fan. Face dampers are very difficult to work with in proportioning airflow. We try to stay away with them and tell a lot of people when they're putting them in, be careful. The other thing is the owner can adjust them. You know, the occupant can adjust them and change them all the time. So, and that's how, you know, if I'm in a hotel and I laugh and it doesn't seem right in that bathroom, first thing I'll go, I'll just open up my face damper. So most of the time it's already open. So, but tolerances are difficult to obtain. Face dampers can be noisy. They do go open and close. They get very dirty on exhaust systems. So anytime you can say, hey, caution on face dampers when you're looking at a job, look at different options. That would be question. We just ran into jobs, got a bunch of automatic flow devices on airflow. Has anybody, I've tested a couple in a lab, but I've never used them or tested them in the field. The contractor who put them in said he's curious, but they went through and did some preliminary testing and said it wasn't even close. The other thing is when you have your dampers installed and your balancing valves installed, just a little caveat, work with to make sure the insulation spec, the insulator, everybody's on board, that in the damper handle, that all the extension ports are provided to get it outside the insulation. So it makes a big, big difference on a job when you have that instead of trying to cut into things in that side. So extension ports are a very, very big benefit. Controls. Probably one of the bigger challenges that we always keep thinking with technology, it's going to get a lot easier, is working with all the teams involved and even working with your controls company today, tomorrow, saying, hey, what kind of access am I going to have? What can you do for me? What can we put together? How can we work on this? I mean, I just ran into our one room and just started grabbing a few things off our shelf, and that's just minor compared to what our guys carry in the van to access different control systems. It seems to be more regional, because I laugh, I'll come to a meeting like this and somebody will say, geez, brand X, we can't stand them in our area. They're great in our area. And brand Y, love them. In our area, I can't stand them. It's interesting the dynamic we see with controls. And I think after the discussion, we had one last night at dinner, was it depends on the tech and the programmer you get. All the companies usually can provide very similar capabilities, but it's the tech and programmer who knows how to use everything that's put in front of them properly and put it together properly, make a big difference how the project goes together and works. But then for the whole picture to say, one, make it user-friendly for the owner, but two, make it user-friendly for the commissioning agent and the tab technician who are out there working, trying to use it to go through it on that side. So all the proper interfaces. I said, we're fingers crossed. So many of them are going web-based. They're going app-based now. A couple of them are going wireless, which we'll see. Communication's slow, but if I don't have to climb up on a ladder, get up and plug a cable into a box, get off the ladder and do that, hey, it might be better. So there are some developing apps and doing some different things. So hopefully this will get better and the coordination of it will be better. The one thing you'll run into quite a bit though, front-end-wise still, bring that conversation up early on a project. Who's providing the front end and who's providing the internet connection? And when will the internet connection be available and live? Because sometimes you need that availability when you're commissioning or you're balancing. And when will the front end be loaded up and ready to go? One thing we run into occasionally, plumbing pumps, fire pumps, steam condensate pumps. The biggest thing to think of is you need constant flow, number one, to take a flow measurement. So if that pump is running and producing flow for 2 or 3 minutes and shuts off, you're probably never going to get a good flow measurement on that. If the pump, probably what, 10, 15 minutes I would think would be good enough to where you get a stabilized flow. The only problem with that is if it's open to atmosphere, you might not have a good pressurized system to get a good stable measurement across that balancing valve. So think of the different types of systems. I think in 15 years I've tested one fire pump, and that was put a 500-gallon tanker outside that had a sight gauge on it, turn the fire pump on, and sit with a stopwatch. That's how we tested the fire pump for capacity. Why? The fire inspector wanted to do it. So for occupancy, they had to do it. So you get, once again, you get creative, but looking at some of the scenarios and what you want to do, make sure everybody understands up front what you want to do, how you want to do it, and those type of things in the planning process. Makes it a lot easier that way. The one thing when we start talking domestic or potable water, the tab instrumentation by all the manufacturers is not certified rated for potable water. So the first thing you'll see in their safety warnings is it's not to be used on potable water. Alnor, Shortridge, they're all not FDA graded. They're all not rated. Plus the fact, if you think about it, the guy just got through working on a chilled water system with glycol. Now he's going to go tap into a potable water system with it. You know, he can flush and clean all he wants, but the liability, I don't think you want to go into that scenario. So once you start talking potable water systems, lab DI water systems, and those type of things, start thinking what we'll call non-invasive, and start recommending a non-invasive method so that you have ways to do that. It could be an ultrasonic flow meter. You can do pipe surface temperature, permanently installed gauges. Great option on domestic hot water reheat systems. Temperature gauge off each of your loops. Take it back to your DDC system. They know right away what they've got. You still need a balancing valve to set your flows and make sure you got it all proportioned out, but you can proportion it by temperature. And for a lot of large complexes with large domestic water systems, so large hotels, hospitals, great to have that feedback to a DDC system of what their domestic water system is doing and why the patient over in room 317 isn't getting any hot water. Quick look at your DDC system, make sure the hot water recirc system's in line with everything else. Could tell you a lot, or it just might be the mixing valve at the room. So look at your different options there of what you can do. And like I say, consider installing temperature sensors on it to report back to the DDC system. You know, simple office building, probably not as critical. You know, hospitals, different things like that. Even for a large hotel, to troubleshoot real quick where my domestic hot water recirc system's having an issue off a DDC system versus sending a guy around, walking around, checking everything is probably, I think, a time and money saver. One of the things that helps both commissioning, test and balance, and owner usage in the end is unique tags and IDs. I mean, when you get to a job and all of a sudden I have 5 VAVGs, not individually identified. The schedule's, okay, yep, I got a VAVG, here's one, put that there. Becomes very difficult in the communication process, through the project. I'm talking to the controls guy going by, hey, yeah, VAVG, yeah, northeast of room 111, it's not holding its calibration factor. So he goes, he gets turned around direction, so he goes and works. No, it is, yeah, it is. Let alone now he's called it, typically the controls guy will call it and put a room number behind it where the thermostat's located. The contractor will label it by where it's actually located. So now we've got all kinds of different nomenclature going back and forth. If we can promote in our industry that these guys build a good schedule, because then your max min airflows are all scheduled correctly, your GPMs, your reheat coils are sized properly, you develop a good system through the whole process, let alone when the owner takes occupancy, everybody's calling the VAV the same thing, so his maintenance staff knows what he's working with. Whether it's heat pumps, VAVs, air handlers, we have one engineer that does a great job, he just simplified it. VAV-1, it's off air handler 1, dash whatever number. If it's VAV-2, you already know you're on air handler 2. Great little systems like that help out in the whole process when you're building the job, and more importantly, when the owner's using and occupying the job. But you can do that in the drawing phase and that side, and it really helps out. The other thing that we look at when you start seeing auditoriums, gymnasiums, high ceiling areas, and we get these wonderful architectural clouds and things like that, and these were put in for acoustics, and not only acoustics, but to hide every VAV box. So you can't see them now. Well, you can't get to them either. So one, the owner can't get to them to maintain them. Two, getting to them to try to get a traverse to get all your airflows, and those was impossible. Because once the seating was installed, access up there was negated. Now, the usual, seating wasn't installed early, and they said, well, you should have gotten in there early and got it done. There's no power to the air handlers yet. There were no power to the VAV boxes. So scheduling becomes a challenge in that side also of situations like this. Start talking to them early and say, hey, by the way, how are we going to get to measure those airflows? How are we going to get to those boxes? How's the owner going to maintain that box? It's got a reheat coil. If he's got to clean the coil, how's he going to get to that reheat coil and clean the coil? The strainer on the coil. So different things like that where you can start looking at things in that side. So we run into this more than I would like to say. I'd say every gym, every auditorium in that scenario. Flow hood. So I said earlier we'd talk about some flow hood applications, that type of thing. The biggest thing to remember, it's a proportioning device. So if you look at all the manufacturer's data, it's not a flow measurement device, it's a flow proportioning device. They'll tell you you're going to take that, put it up to the outlet, but you should establish a correction factor for what that's measuring with a duct traverse, okay? Most of your tap professionals know that type of ceiling diffuser, a 2x2, a 2x2 plaque diffuser, they read pretty well spot on. A 1.0 correction factor is what's needed. So experience through time as well as certain jobs, a lot of times the way the flex duct gets connected to that can actually dramatically, I should say, affect how that airflow goes. You can stand here and face one direction and measure it, face all four directions, get 4 different readings based on that velocity profile, how it's coming out of there. Because that flow hood just has a flow sensing grid in it, and that's what it's using. It's using that flow sensing grid of how that airflow is coming across that grid to measure the airflow. So be careful that it's a proportioning device. Know how to use it properly, cover the whole outlet. Boy, frustration in life when you look at fume hoods, BSCs. There's an organization, that's how they tell you how to do it. Put your flow hood up. Or get a custom-made hood that's 18 inches high, 4 foot wide, or whatever. I don't think that's how that flow hood's going to be, or the fume hood's going to be used. I don't think they're going to put cardboard here, tape it off, and just work through this area, let alone the back pressure that creates. So, if you're out there and you see some people doing some things, question it and look at it. So, and think about it, but don't always think that flow hood's the magical device. Just because it says CFM on the display doesn't mean that's really the true CFM. Always needs to be enough time in a schedule to get the tab work done, to get the commissioning work done, and y'all always know they always put a ton of work time in there for that. So it's always funny when you start going through it and you sit down and you talk to them how much time you need. I truly think commissioning has helped the process because y'all have the owner's ear more and saying, hey, here's what I'm going to need time-wise to commission. Here's what needs to be done before I can start commissioning. And they're listening. And now when the owner goes to the general and says, or the CM, hey, I need stuff by here so my commissioning guy that I've hired can get in on the job and get it done. Very seldom does that point does the GC or the CM come in and say, I know you're not getting it. As a tab contractor, I come into the GC, hey, here's what I need. You got to find a way to compress that. Yeah, you got 1 week, make it work, you know. So I think the overall process with the commissioning getting involved in that time, these actually helped out the scheduling process and getting that thing done. So always talk schedule, and that side. The hardest thing of schedule that most GCCMs and even owners don't understand, typically majority of our work is done by system. It's not done by an area. And typically majority of your HVAC systems are horizontal or vertical, not horizontal like a building. So they're going to phase out a building by floor. Your air handler's sitting up top feeding each floor, constant volume system. How are you going to do a floor at a time if they haven't finished out the other floors? Or your reheat water system. You know, large system or your chill water system, they don't have all the air handlers hooked up yet. So getting involved early on scheduling, saying, hey, by the way, you're phasing the job. What are you doing? How are you going to do that? You know, air side, don't be afraid. I laugh. We go into one and they had a multi-phase project. We sat down with the consultant early and said, hey, you know what? Here's what you're going to have to do. On your energy recovery exhaust and your energy recovery supply into each area, you have to put a VAV box into each phased area. So they finished the phased area. We calibrated the box, set up the airflow. It's on a VFD. We could back it down, put a limit. We never had to go back in that space again. All we had to do is verify that we had the right static pressure set point for that VAV box serving that phased area. So it's a big dental school. They were able to move all their patients, do all their dental work that way, and just move their people around. We never had to get back to that area. We got back there for one thing, the reheat water in the VAV box, because we could not get all that done at the same time. So start thinking creatively, how can we use different equipment, how can we use different systems to do it in that scenario? So worked out very well. Tab reports, probably the biggest thing I can say about tab reports is the bottom line. You know, it doesn't benefit a tab agency or even a commissioning company to publish problems, to talk about issues they had on the job, to go through that and, you know, hey, I couldn't get design airflow here. It doesn't benefit the tab agency. It doesn't benefit the CX company to say, hey, this sequence isn't working right? The benefits to the owner. The benefits to the design professional so that he can evaluate the system. You know, and I always laugh and look and say, hey, that pristine report where all the numbers look great, that's the one we got to sit there back and step back and say, hold on here. Everything looks great and everything's good, especially if you got a large project. You're going to have issues, you're going to have challenges. So, you know, welcome the reports that have the challenges listed in them. Don't immediately say it's rejected, this doesn't meet approval. Start looking at it and saying, hey, why, how, does it make sense, can I live with it, those type of things. So take your time going through a report.